Good afternoon, one and all present here. This is the second topic of the engineering graphics and modeling through AutoCAD. And the topic is conic section. In the conic section, there are three shapes. First one is ellipse, parabola, and last one is hyperbola. This curve appears on the surface of a cone when it is cut by some typical cutting plates. Conic sections, ellipse, parabola and hyperbola, called conic section because this curve appears on the surface of a cone when it is cut by some typical cutting plates. This is the cone, and this line is the center line which moves from the apex to the base. This is the center line or imaginary line or axis. If this conic section is cut at any angle to the axis, then ellipses are shown on the surface of the cone. When the cone cut parallel to one of the generator, then we obtain parabola. This is the parabola. And the third one is when this cone is cut parallel to the axis, this is the section plane which is parallel to the axis, then we obtain hyperbola. Ellipse having 6 methods, parabola having 3 methods, hyperbola having 3 methods. By all these methods, we construct ellipse, parabola and hyperbola. For construction of ellipse, the first one is the concentric circle method, second one is rectangle method, oblong method, area of circle method, rhombus method and basic locus method. That is also known as general method. In parabola, rectangle method, method of tangent and basic locus method. Third one is hyperbola. First method is rectangular hyperbola, that is the coordinate system. Second one is the rectangular hyperbola with the help of PV diagram. And the third one is the basic locus method, that is general method. Common definition of ellipse, parabola and hyperbola is these are the loci of point moving in a plane such that the ratio of its distance from a fixed point and a fixed line always remain constant. The ratio is called eccentricity. For ellipse, the eccentricity is less than 1. For parabola, eccentricity is equal to 1. And for hyperbola, eccentricity is greater than 1. Now, draw an ellipse by concentric circle method. Take major axis 100 mm and minor axis 70 mm. So we draw the major axis, that is equal to 100 mm, and at the center we draw the minor axis, that is 70 mm. Taking their intersection point at center, draw two concentric circles considering both as respective diameter. This is the first circle and this is the second circle. Divide both circles into 12 equal parts, or we can also divide it into 8 equal parts, but here we divide it into 12 equal parts. From all points of the outer circle, this is the point of minor circle, and Divide both circle into a equal part and name is shown in figure. From all point of outer circle, draw a vertical line. Draw a vertical line which is parallel to the center line, and from the upper part of the circle, draw a vertical line toward downward, and from down the line will be moved toward upward. But in both the time the line is parallel to the center line. And from inner circle, draw a horizontal line to intersect that vertical line. And we can naming the intersection point of these two lines like this. And draw a freehand sketch curve to join all these points like this. This is known as ellipse with the help of concentric circle method. Now the rectangle method, there are same, the major axis 100 mm and minor axis is 70 mm, and we naming that name, that is DC for the minor axis, and draw this one part of this rectangle, divide into 3 parts, and that horizontal line is also divided into the same equal part, and draw all the vertical lines to the point D, and from the C draw all inclined line from 1 to 2, 3, as one point is cut the first line, second point cut the second line, third point cut the third line, and that intersection point may be designed like this. And the same process is going for all 4 parts in the same way. So this is known as ellipse with the help of a rectangle method. Now draw the ellipse by oblong method. Draw a parallelogram of 100 mm and 70 mm long side with the included angle of 75 degree. Inscribe ellipse in it. So it is the same process as in rectangle method, but here it is a parallelogram, so the included angle is 75 degree, and the process is same as in a rectangle method. Divide this rectangle into 4 equal parts, and each part is a rectangle. Then divide into 4 equal parts, as same is divided into horizontal line with 4 equal parts. Join all these points to the center point, and from down point, draw all the inclined line from 1 to 1 line, second to second line, third to third line. This is the intersection point, and the same process is going. So like this, we draw an ellipse with the help of oblong method. This oblong method is also known as the parallelogram method. Now the ellipse with the help of arc of circle method, as major axis AB and minor axis CD are 100 mm and 70 mm long respectively. Draw ellipse by arc of circle method. Draw both axes as usual, name the end and intersect point. Taking AO. This is the AO. Distance L, half major axis from C1, and mark F1 and F2 on AB. That is focus F1 and F2. On line F1, 0 taking a distance, mark point 1, 2, 3, 4, and same process from this side. From B1, name the point P1, P2, P3, P4, and repeat this step with the same center by taking now A2 and B2. Distance from drawing are, name the point P2. Similarly, at all other P points, the same state position of P can be located below AB. Join all points by smooth curve to get an ellipse. Now next method is rhombus method. Draw rhombus of 100 mm and 70 mm long diagonal and inscribe an ellipse in it. Draw rhombus with the help of given dimensions. Mark midpoint of all sides and name those A, B, C, D. Join this point to the end of this smaller diagonal, mark point 1, 2, 3, 4 as a 4-center method. Okay. And this method is also used in the last topic, that is known as isometric projection, with the name of 4-center method. There we can draw a circle with the help of this method, like an ellipse. Taking 1 as the center, 1a radius, draw an arc AB, take 2 as the center, draw an arc CD. Similarly, taking 3 and 4 as center and 3D radius, draw an arc DA and BC. Like this. This is draw an arc with the help of 3, and 3 to A is the radius for this circle. So we draw an arc like this. Now take 4 as the center and draw an arc from B to C. Take 1 as the center and draw an arc from A to B. Now take 2 as the center and draw an arc from C to D. This is known as arc of circle method. Now the general method, where the point F is 50 mm from a line AB, or point P is moving in a way such that the ratio of its distance from F and line AB remain constant and equal to 2 by 3. Draw locus of point P, where the eccentricity is 2 by 3. Now this vertical line is known as DIRCTRIX, and this is the horizontal line on which we find focus at the distance of 50 mm. Now 2 by 3 is the eccentricity, so 2 plus 3 is equal to 5. So divide this 50 mm into 5 equal parts. And 2 by 3, so the 2 is from distance taken from the focus, and 3 is distance taken from the diameter. So the intersecting point from focus to second point, that point is known as vertex. That point is known as vertex. Like this. This is a vertex. From more point giving same ratio such as 35, 45, 40, 60, etc. Taking 45, 60 and 75 distance from the line AB, draw 3 vertical lines to the right side of it. Now with the 30, 40 and 50 mm distance in compass, cut this line above and below with F as a center. Join this point to B in a smooth curve. This is the required locus of P. It is an ellipse, like this. This is a parabola, and the method used to draw parabola is rectangle method. Suppose a ball thrown in the air attain 100-meter height and cover horizontal distance 150. So this the length of this horizontal line is 150 meter, and the height of this parabola is 100 mm. Draw a rectangle of above size and divide it into 2 equal vertical parts. Consider left part for construction. Divide height and length in equal number of parts and name this 1, 2, 3, 4, 5, 6. And the same in the horizontal line. Same part. So join vertical 1, 2, 3, 4, 5, 6 to the top center of the rectangle. And similarly draw upward vertical line from 1, 2, 3, 4, 5. And wherever this line intersect previously drawn, inclined line in the sequence. Mark those points and further join in a smooth possible curve, like this. This is the intersection point that we will join, and this is the smooth curve. This is known as parabola. You must understand that the vertical line, if we divide the vertical line into 6 parts, then we divide this half horizontal line into 6 parts. If we divide this vertical line into 8, then divide this half line into 8. So this process is going on, and the same first point is cutting the first line, second point cut the second line, third point cut the third line. This is known as the intersection. Now, method of tangents. This is the triangle method. Draw an isosceles triangle of 100 mm long base and 110 mm square parabola unit by a tangent method. Now, divide this line into 10, 12, 13, 14. Minimum 10 part or 9 part. We must have divided this line into 9 or 10 parts. But here we have divided into 14 equal parts. And start counting from this side, that 1, 2, 3, 4 to 14, and now divide this line, counting start from downward 1, 2, 3, 4 to 14, and join this first to first, second to second, third to third, fourth to fourth. Divide 1 to 1, 2 to 2, 3 to 2. This process is going on, and now you will see that this curve is generated with the help of this intersection point. Now the same method, general method for the parabola. This is the directrix, this is the horizontal line, and the distance of the focus from the directrix is 50 mm, and this is the vertex where 1 by 1 is the ratio at the time of parabola. So we divided this into two equal parts. 1 by 1 means 1 plus 1, that is equal to 2 vertex. Now the process is same, like locate at center of line perpendicular to AB from point F. Point F, this will be initial point P and also the vertex. Mark 5 mm distance to its right side. Name those points 1, 2, 3, 4 from those draw line parallel to AB. Now mark 5 mm distance to the left of P and name it as a 1. Take O1 distance as radius and F as center, draw an arc cutting first parallel line to AB. Name upper point P1 and lower point P2. Now the next method is rectangular hyperbola method. Point P is 40 mm and 30 mm from horizontal and vertical axis. So draw a rectangle of 30 into 40 mm, and after that increase this line without any measurement and divide this 40 mm line into 3, 4, 5 equal parts, and from taking O as the center and draw all the line from O and increase from the point 1, then 2, then 3 to this horizontal line where they join. After that draw a vertical line from point 1, then 2, then 3, and a horizontal line from vertical line 1, 2, 3, and that intersection point, this is like an intersection, move a curve from 2 to 1 to P, 1, 2, 3. This is known as a rectangular hyperbola. And in PV diagram, a sample of gas is expanded in a cylinder containing pressure to 1 unit pressure. Expansion follow law PV equal to constant pressure and volume. If initial volume being 1 unit, draw the curve of expansion, also name the curve. From a table given in a few more values of P and B. 10 into 1, 5 into 2, 4 into 2.5, like this, then PV is equal to C, as C is constant. So when we do multiplication, always we want a multiplication and always we want a constant value, that is 10, and draw like this. This curve is known as hyperbola. Now draw a curve of pressure volume against volume. It is a PV diagram and it is hyperbola. Take pressure on vertical axis and volume on horizontal axis. Now this is a directrix focus method, or we can say that a general method. Draw a line directrix and horizontal line on which we find a focus at the point at a distance of 50 mm from it, and the eccentricity is 2 by 3, so the sum of 2 by 3 is equal to 5. So divide this line in 5 equal parts from the directrix to the focus, and the 2 by 3, so from focus take to second point is vertex and draw a line VF is equal to VE, and start a point from D, which move with the help of E.